Hello everyone, here I'm Taran Sritaran Vasu from DBT 4B from Polytechnic Nilai Negeri S Milan. So, today I'm here, the purpose I'm here is to explain about protein isolations and also carry out the protein isolation simulation. Okay, so before we going further to our simulation, I would like to explain a bit about protein isolation. As you guys know, proteins are present in all living organisms and includes many essential biological compounds such as enzymes, hormones, and antibodies. I bet before that you guys heard this name, or you guys must be familiar with these types of biological compounds, which is enzyme, hormones, and antibodies. So, protein is a complex substance that consists of amino acids, which is were joined by peptide bond. Next is we move to protein isolation. Protein isolations is a collections of samples, washing and cleaning or grinding powder. Also undergo cell lysis with physical grinding and chemical, which is lysis buffer, and also actually this is steps of protein isolations. First of all, collections of samples, washing, cleaning, and grinding to the powder, cell lysis with physical and chemical lysis buffer, and then they move to next processes, which is next steps is separations of protein from non-protein compounds and recovery of bulk proteins. For further separations of proteins will containing a fraction from the bulk protein, recovery of proteins in a highly purified state along with a high yield. Okay. The aims of protein isolation is to separate the proteins from where is in such a form as they remains as far as possible. Thus, and then they retain their function. Next, and then okay, protein purifications. There is three common steps, which is lysis, ultracentrifugations or centrifugations, and chromatography process. Okay, lysis is a break cells opens, and then ultracentrifugation is a collect the soluble protein, and they usually spin the soluble protein to pellet out the membrane pits, and then the chromatography is for separate your protein from all others.
Okay, here is the simulation for purifying protein by chromatography. So first is pellets to cell. So we want to spin the EC tubes in microfree for 10 minutes in order to separate the cell from the media coat. So here we got two E. coli. Okay, so we'll finish the cover. Okay, for 10 minutes. And then, okay, next steps, after you centrifuge, we remove the EC tube. You place back into the solute rack, solution rack. And one more thing, make sure when you put the centrifuge tube inside the microcentrifuge, which is you check the balancing first before you start the centrifuge. And then next, open the EC one. Okay, and open the measure procedure and open the waste collection bar and tilt or pull the waste the supernatant without disturbing the cell platelets at the bottom. So we place it back here. Okay, next is set the P 1000 micron difference. Same support. Okay, we set up the pipette. Let's make a pipette. So increase the microliter and okay. After you attach the tube, then open the EC tool and draw 100 micro microliter of liquid. Sure. Then okay, so this was the culture into one. Damn it. Okay, draw 1,000 microliters of liquid. And okay, once the spectacle changer to the EC1 tube, and then open the biohazardous container. And eject the tips into the biohazardous container. And spin, okay. Spin EC1 tube for about 10 minutes. Then after that, remove the EC tube. And then open the EC tube and open the waste collection term to turn the supernatural pellet 150 microliter. Okay, and then attach the tips. And open the eBay tube, which means the elution buffer. Cell draw up around 150. 15 microliter, and dispense into the E1 tube. Okay, after dispense into the E1 DC1 tube, attack the tube. Lyses the cell. So for you will text the EC1 tube for about 10 seconds, and the cell pellets. Okay, attach the tips for 200 micropipette. And the LY tube, which is lysis buffer, known as lysis buffer. So draw about 500 microliter of lysis buffer, and then disperse the lysis buffer into EC1 tube. So put back the lysis at EC1 rack. So disperse the lysis buffer into one tube. After that, open the biohazard waste as usual and eject the tips to the biohazard waste container. And then centrifuge. So after you strength, you set a timer for 12 hours to incubate EC1 tube overnight room temperature. So since the centrifuge done, so we're going to set a timer. Okay, start. 12 hours. Then done the lysis process after. Let's equilibrate the column. First, we place the paste collections under the wall of the chromatographic column. After that, open the column strings to await the liquid. Spin. We open the column to drain away the liquid. And done. After that, we spin. Okay, where's spin the EC1 to 10 minutes. Okay. Right, and set the pacing. Now should set the microPEP 2200 micrometer. For this we use to set 150 microliter. So attach the tube and open the EC1. Make sure you guys always check the balancing before you centrifuge the tubes. So open the CR and draw also supernatant and open the super tube. Dispense the supernatant super tube. Then as usual after done the process you should check the tubes should open check the tube. Check the tubes. That's for equilibrate the column. Next next will be equilibrate the solid reflections in BB. So first of all attach the new open the BB which is binding and draw up to binding buffer and this present be into separate tube. And then eject the tips. Then next apply the soluble friction to the core. So pick up the P1000 micropipette and open it export. Attach draw 400 microliter of super solution and then disperse into the chromatography column. Okay, and as usual, take the tips. Okay. And place the water collection jar back on the roof. Open the column and add liquid frame to the waste control plus just above the missing bed. When it's done, just close the roof when the liquid is just above the missing bed. Then next will be washed. So set micropipette to the new tips. Okay, next is one pipette to attach and then dispense the wash buffer about 1000 microliter and then open the biohazard container and eject the tips. And open the columns around the door to the drum and close the valve while the liquid is just erasing that. Once done, move to next step. Draw absorbs thousands microliters of UV solution and dispense them gently inside columns. Repeat. And open the column. Open the convection which the weight bottom travel to columns when its met bottom close. Done. Place the open RFQ tube under the valve. U and open the column to capture. Capture RFP and close the valve. And then dispense add into the pushing ball. So then dispense 100 not 100 microns of columns here. Dispense 1,000 micron to column buffer solution, column incorporation buffer solution. So and then open the. Okay, make sure you repeat colorway. Save it to this, and then done. Okay, summaries. In the simulation, you learn how to purify a protein from a spectra using chromatography. The simulation explored how two mice where cells have been transformed into treatment plasmid expressing with fluorescent protein. They also prepare hydrophobic interaction chromatography columns and apply secondary protein column. Use a buffer of different salt concentrations to separate, purify, and elute RFP, the protein of interest on the chromatograph.